Number 1, quotient. When you're finding the quotient of something, that means division. This says the division of 8 or the quotient of 8 and x. That means you're going to do 8 divided by x. Can we all agree that is means the same, is equal to? That one's pretty self-explanatory, right? 5 less than. 5 less than doesn't mean you're going to do 5 minus something. It means you're going to do something minus 5. That's a turnaround phrase. Now, what am I going to subtract 5 away from? I'm going to subtract 5 from the product of 10 and x, which is 10x. So for number 1, you should have an equation written very similar to that. As long as you know what quotient, less than, product means, you will be just fine on Friday. So make sure you know what those terms mean. And especially the less than means you take away that number, not you're doing that number minus something else. Questions about number 1? All right, number 2. It says the number 2 is added to a number. What do we use when we don't know what that number is? X. Or any variable, correct. I'm going to be boring though and use x. The sum is multiplied by 12. Okay, so here's the problem with how I have it written right now. It told me the sum is going to be multiplied by 12, which means I have to add and get a sum in the first place before I can multiply. So what needs to be added to my equation? Go ahead, ma'am. Parentheses, right, to make sure that you add first. The way I had it written, you were going to multiply first because that would be proper order of operations. Put the parentheses around that sum, and then, of course, the result is 14. It's just another way of saying equals 14. Yes, sir?
Does it matter where we put the 12? Does it have to be on the opposite?
That is an excellent question, Mikey. You just does not matter. You can put it. You could put it in the front or in the back.
Well, I was just curious because if we put it in the front, I'm used to it being there for distributive property.
That's very true. Either one would be correct. So 12 times x plus 2 or 2 plus x, doesn't matter. It means the same thing. That is a good question, actually. Thank you for asking a good question. All right. Any questions about number 2? All right. I know I'm cracking myself up. Okay, number 3. I saw the same mistake over and over and over and over again. So please don't make this mistake on Friday. A lot of you guys chose to get rid of the 5, which I agree with. That's fine. Get rid of the 5. How do you get rid of dividing by 5? You multiply, right? Here's the problem. A bunch of you guys did this, which isn't wrong. You just didn't multiply 5 by everything. If you choose to get rid of the division first, you must multiply everything. That's why typically I recommend starting with this one first, because people make fewer mistakes that way. Doesn't matter, it's fine, but if you're going to cancel out the division first, remember you have to multiply every single thing. So those cancel, leave you with the u. 5 times 6 is 30. 5 times 2 is 10. And then to isolate the u all the way, you just do minus 30. U is equal to negative 20. So if you choose to get rid of the division first, you have to multiply everything. Remember the other way? The way that personally I kind of recommend, because people mess it up less, start off by doing minus 6 on both sides. U over 5 is equal to negative 4. Multiply both sides by 5. Notice you still get the same answer. So either way, it doesn't matter. If you add or subtract first, adding and subtracting, you have to have like terms to add or subtract. So you only do that twice. Multiplying, dividing, you got to multiply everything. So make sure you keep that difference clear in your head.
Do we need this?
You won't need a Chromebook at all. Good question. Thanks. All right, number 4. So notice number 4 is different from number 3. I'm going to clear out number 3 just so you can get a closer look so you can see the difference. Problem number 3, we had to multiply 3 different times because the 6 is not on top of the 5, right? It's its own separate entity. Over here on number 4, though, the 13 is on top of the 12. So you have no choice. You cannot do minus 13 to start. You have to get rid of that 12 before you can get rid of anything else because that R and the 13 are both trapped on top. Okay? So, how do I get rid of a 12? I'm going to multiply, correct, because this is dividing by 12. The inverse is going to be to multiply. Here's the other thing I don't want you to do. Don't do 12 times R and 12 times 13. That 12 cancels out with the 12 in the bottom, so there is no 12 to multiply in the first place. So this should just be R plus 13. If I multiply the left-hand side, I multiply the right-hand side. Still need to isolate the R by doing minus 13. R is equal to negative 1. So pay very close attention to the difference. 4, you had the number and the variable. 3, the number was not sitting above that number, so you still had to multiply everything. There's a big difference. 3, you got to multiply all 3 terms. Number 4, you just multiply twice.
It is fine if we do subtract the 6.
Yeah, I don't care if you do minus 6 first. Yep. Most people have been choosing to do it this way, which is why I keep harping on that, because when we keep choosing to do it like that, we keep forgetting that middle term. But yeah, if you just want to do minus 6 on both sides first, then cancel out the division, that's great. In fact, that's my recommendation because you mess it up fewer times. Anyway, all right, questions about 3 and 4. All right, number 5. This 8 is sitting here on the same side of the equal sign as the variable. There's actually several different things you could do first. I'm going to do what most of you guys have been doing, which is getting rid of that 8. So that's dividing by 8. How do I get rid of dividing by 8? I multiply by 8. So I'm going to multiply all 3 terms by 8. So 8 times 8 is 64. Those are going to cancel each other out. Minus 3m. And then 8 times negative 4 is negative 32. The part that a lot of people have been messing up on that one is remembering that this is a negative that needs to be brought down with that 3m. So be careful and make sure that you don't make that mistake. So now we need to get the m isolated. And so you could do a few different things. You could go ahead and divide by 3 if you wanted to, but I wouldn't do that because 32 divided by 3 turns out to not be a whole number. So what I would do instead is get rid of the 64. And that is a positive 64. Even though, I'm going to wait a second because I'm struggling to concentrate right now. Thank y'all. All right. So if you get rid of, or if you look at that 64, there's a minus, but that minus is in front of the 3. That's not in front of the 64. That's a positive 64, which you're going to get rid of by doing a minus 64. So those are going to cancel. You're going to bring down, it's not just a 3m, it's a minus 3m. And what I do on one side, of course, I have to do over here. You're going to combine those to get negative 96. I cannot stress enough how much I've seen people not get these right because of their integer rules, like adding something wrong, subtracting something wrong. Guys, your 7th grade year got cut off early when a lot of teachers are doing positive and negative numbers. If you got to rely on that calculator to double check and make sure you're doing it right, do that, please. Don't mess up the whole thing just because of your integer rules, which a lot of us are doing right now. So then to get rid of that negative 3, I'm just going to cancel out that multiplication by dividing. So m is equal to positive 32. Questions about number 5?
No, it's something easy.
Great. I'm glad you feel that way. Number 6. Is it okay if I zoom in on number 6? Anybody still checking number 5? Okay. So number 6 is pretty similar, actually very similar to number 4. It's pretty much the same thing. That is trapped above the 5. That means the 5 is going to have to be gotten rid of first. How do I get rid of dividing by 5? I multiply by 5, which is going to leave me with 3k minus 7. You don't multiply 5 by 3 or anything like that because there is no 5 because it canceled. What you did on one side, though, we have to do on the other side. So that leaves me with 80. And I'm going to get rid of that minus 7 with a plus 7. And last but not least, I'm going to divide both sides by 3. And so K is equal to 87 over 3. Oh, that's not true. That simplifies. 87 divided by 3 is, let's see, 29 over, oh yeah, that divides out to 29. My bad. Didn't even realize it for a second there. So K is equal to 29. Okay, questions, comments, or concerns about number 6? All right, number 7. We're getting there, we're getting there. Okay, here's what a whole bunch of people have been doing wrong for number 7. Oh my goodness. First of all, we get the distributive part right. 1/2 times 6 is 1, I don't know why I just wrote that. 1/2 times 6 is 3. And then 1/2 times negative y is negative 1/2 y. Okay? And then we just bring the other side down. If I were you, because I keep seeing people trying to like add 1/2 y to each side, and that's fine. You can definitely do that. But then we keep making mistakes when we go through and we add them together. What's technically in front of that y? It's a 1, right? So this really means 1 plus 1/2 is 1.5 y. So then technically what you would do is just divide both sides by 1.5. But let me show you what I personally would do instead, because I think you guys will make fewer mistakes. Once you do that distributive property, get rid of that 1/2. How are you going to get rid of that 1/2? You're going to multiply everything by 2. Exactly. So personally, I would get rid of that. And I would do that by multiplying everything by 2. So 2 times 3 is 6. Those 2's are going to cancel, so you're just going to have a minus y, because you don't really need that 1. And then this will be 2y. So now you've got a variable on both sides. One of them needs to go. Personally, I would get rid of the minus y. How do you get rid of the minus y? With a plus y. So 6 is equal to 3y. And isolate the variable all the way. Divide both sides by 3. 2 is equal to y. Okay. Any questions about number 7? All right, number 8. First things first, I got to do my distributive property, right? So I'm going to do 3 times negative 2, which gives me negative 6. I'm going to do 3 times negative 3x, which gives me negative 9x. And I'm just going to bring down this other side. So maybe, if you're a little observant, you're going to notice something. I've got the same x's on both sides of the equal sign. Can you put them together if they're on opposite sides? No. So I can't combine them. They're exactly the same though, right? And I've got a different number to balance out with them. So if you haven't already thought about that, exactly the same x's with different numbers, that will never balance out. The one that has a negative 6 is always going to weigh less than the one with a negative 4. If you didn't notice that right away, though, that's okay. Get rid of a variable. Do the opposite of minus 9x by doing a plus 9x. And the variables are going to cancel out, and so hopefully at this point you're going to notice, oh wait, the variables canceled out and left me with an equation that's false. This is no solution. Okay, so any questions about number 8? Cool. All right, we're going to go through this pretty fast. Okay, number 9. Once again, I've got distributive property to do, but I've got 2 sets of it. 2 times a is 2a. 2 times negative 8 is negative 16. That plus 7 is just sitting there waiting for something to do, so hold the phone for a minute. Then we got 5 times a, which is 5a. 5 times 2, which is 10. And then that minus 3a and minus 19 had nothing to do with distributive property. We just needed to bring it down for a minute. So I notice that on the right-hand side, I've got a 5a, take away 3a. They're on the same side of the equal sign. That means I can combine them. I can put them together. That also means that I've got a 10 minus 19. 10 minus 19 is negative 9. Over on the left-hand side, I can put together that negative 16 and that 7, so I get minus 9, and bring down the 2a. Do we notice anything weird about this one? Exactly the same variables on both sides. 2a, minus 9, minus 9. What do you get when you've got exactly the same two things on both sides? We are going to infinite number of solutions. If you didn't notice that, when you go to cancel out the variable, you notice it's going to cancel, and you're left with negative 9 is equal to negative 9. Either way, whether you noticed it earlier or not, this is an infinite number of solutions. Or when you get to Algebra 2 in a couple of years, they will call it all real numbers. Okay, because that means you could literally put any number in the planet in there and it'll always balance out. Two ways of saying exactly the same thing. Okay, questions about number 9. Okay, 10, 11, and 12 will be bonus questions on the real thing. So if we have time, I will go back to those. And if not, I'll give them to you tomorrow. But we're going to go ahead and go to the ones that are actually for a grade on the real thing. So I'm going to go ahead and flip over to number 13. So remember, 3x plus 1, they're in absolute value bars. They're in absolute value jail. Okay, so that means you're going to have to do a case 1, which means you hope 3x minus 1 gets out of jail, and they have a positive outcome. However, unfortunately, what frequently happens is we get a negative outcome, thus the case 2. So once you set it up, you're not doing anything you don't already know how to do. You're just setting it up twice. You're setting it up for a positive version and a negative version. So but the good news is you solve it exactly the same way. You're just doing it with different numbers to it. So 3x is equal to 6. Divide both sides by 3. X is equal to 2. Here I'm going to add 1 to both sides. 3x is equal to negative 4. Divide both sides by 3. X is equal to negative 4 over 3, because that's as simplified of a fraction as it's going to get. When you have two solutions for one problem, remember the mathematical way to do that is you do the little brackets. I can't draw the smaller solution and the larger solution with the right bracket that I draw even worse than the left bracket. So I'm not gonna be like crazy picky about this. There may be some extra credit for it in you if you actually remember that's how you need to write it. But the bottom line is you need two solutions for your absolute value. You need to solve it for a positive version and you need to solve it for a negative version, but it's the same question or same equation. Okay, number 14, you might be freaking out and being like, I don't want to do another fraction. But you don't even need to do number 14. Why don't you even need to do number 14?
Oh, because it's negative on the outside.
It's negative. It is absolute value that is isolated and equal to a negative 10. Can absolute value ever be a negative number? No. So you just need to be like, oh, I'm not doing that one because it has no solution. Don't even have to do it because it's got no solution to it. Okay, number 15, remember that you can't do your case 1 and your case 2 until the absolute value is isolated. So right now, absolute value is not isolated, right? This is my absolute value, but I've got that minus 8 and I've got that 2. So we're going to get rid of the minus 8 with a plus 8. And we're going to do that on both sides. So I bring down the rest. And it's going to be tempting to do distributive property, but you're not going to do that. Instead, the 2 sitting next to the absolute value means multiplication. How do you cancel out multiplication? With division. So now you can finally set up your case 1 and your case 2, because that'll cancel. Leave you with 1/2 x minus 1 is equal to 9. So now that the absolute value is isolated.
Where'd you get the 1 to the 1/2 x?
Where'd I get what?
Where'd you get the 1?
That is a really ugly absolute value bar. That is not a 1.
Oh.
Those are my absolute value bars. Sorry, bro. All right, so my case 1 will be 1/2 x minus 1 is equal to 9. My case 2 will be a 1/2 x minus 1 is equal to -9. What I would do if I were you guys is I would ditch that dividing by 2. Personally, I would multiply everything by 2. So that leaves me with x minus 2 equals 18. How do I get rid of that minus 2? By doing a plus 2. So that'll be x is equal to 20 for one solution. And then I do the same thing over here on the other one, multiply everything by 2. So x minus 2 is equal to -18. Still add 2 to both sides. You're just adding it to a different number. X is also equal to -16. So if you're going to put your answer in there like officially correctly, again, there might be some extra credit for you for doing that. Your little bracket, -16, 20, close the bracket. So you've got to have your absolute value all by itself before you can do a case 1 and case 2. Upstairs, when you get to algebra 2 and you do complicated versions of this, what they'll say is like, before you can break your friends out of jail, you got to like kill off the guards. Is what they say. I think that's what they say. It's something like that. It's like knock off the guard or hit him over the head or something that's keeping your friend in jail. Something like that. You got to get rid of them before you can do your case 1 and your case 2. Hey, you remember it, right? So that's helpful. Or at least the kids that I talk to remember it. Okay, questions about number 15? All right, number 16. All right, so we've got one variable. So all we really need to do, that b plus 2 is trapped on top of that 7. So the first thing we need to do is get rid of dividing by 7. How do we get rid of dividing by 7? We multiply by 7. You can, but you do not need to multiply both sides by 5 because you don't have a variable on top of that 5. So is it wrong if you do it? No, but you don't have to because you don't have a variable to isolate on that side. So all I'm going to do is multiply both sides by 7. That cancels. That's going to leave me with a b plus 2. And then over here, 7 times 3 is 21. So that's going to be 21 over 5. You guys have those calculators. All you got to do, use those calculators to subtract 2 from both sides. If you do it correctly, let's see, that would be 4 1/5. Sorry, I'm doing some mental math really quick, which is 2 1/5. So that'll give you 11 over 5. Yes, ma'am. You what? 2.2 is okay. It's not wrong. You're technically correct. But remember, we want to get in the habit of leaving it in a fraction. Once we start graphing and we need slope, it's good to get in the habit of doing a fraction. Will I necessarily mark you down Friday for not doing that? No. But get in that habit, please, guys. Yes, sir.
So you can't multiply on the right side of the equation?
You totally can. Are you talking about, you mean to like cancel out the 5? You can. You're just doing extra work that you don't need to do because there's no variable on top of the 5 that needs to be isolated. So like if it's okay, that's what somebody over here did too if I call you out. Still got the right answer, just did more work than you had to do. So it's not technically wrong. Does that make sense? Now compare that one though to number 17 because now you got a variable on both sides, right? So now you got to multiply by both. So that's the difference between 16 and 17. 16, guys, you only have a variable on one side. 17, now you've got a 4 and a 6 that need to be eliminated. So I'm just going to get rid of the 4 first. How do you get rid of dividing by 4? You get rid of it by multiplying by 4. And I'm going to do it on both sides. But before I do that, I'm also going to go ahead and cancel out dividing by 6. How do I cancel out dividing by 6? I multiply by 6. Okay? So let's see what cancels. Those 4s cancel. Those 6s cancel. So now I'm just left with 6m plus 12 equal to 12m plus 4. I've got variables on both sides, so they need to go. I'm just going to get rid of the 6 because it's smaller. 12 equals 6m plus 4. Subtract 4 from both sides. 8 equals 6m. And finally, we're going to divide both sides by 6. So 8 over 6 simplifies to 4 over 3 as a simplified fraction. I know you might have said like 1.3, like rounded it. That's okay, but please try to get in the habit of leaving it as a fraction. We're almost done, guys. I know study guide days are so flippin' boring, but they're necessary. Huh? You need them, though. They're good for you. It's kind of like eating your vegetables. All right, any questions about number 17? All right, number 18. So we got to get x isolated. We know we need to get x isolated because it says isolate for x. So that's what we're trying to get by itself. So we need to get rid of everything that is on the same side of the equal sign as the x. Personally, I would get rid of the 4y first. How do we get rid of a plus 4y? Minus 4y. Exactly. Okay? If I subtract 4y from the left-hand side, I have to subtract 4y from the right-hand side. So that's going to cancel. Now, can you combine a t and a y? You cannot. So but you still need it over on the other side. So you're just going to have to leave them, it would help if I wrote the right number, as two separate terms. Okay? Then bring down m over x. How am I going to get rid of that m? Divide. Yes. So that cancels. Leaves me with the isolated x. 3t minus 4y over m. So you're just reorganizing it to get the x by itself. Okay. Any questions about number 18? Okay, last but not least, number 19. I can tell y'all are kind of done, so I'll go over the extra credit ones tomorrow. So number 19, this is the last one we're going to do. So we are trying to get a by itself, okay? Which means that we got to get rid of all this stuff sitting over there with the a. So what's sitting there with the a? That minus q for starters. How do I get rid of a minus q? With a plus q. I can't combine a k and a q. So I'm going to do k plus q. And then bring down that 3/4 a. So what I would do next is I would multiply, what I personally would do is multiply by 4 to cancel out the 4s. So that leaves you with 3a. Over on the right-hand side, you've got two choices for how you want to do this, and I would accept either one of them as correct. You can do k plus q and put the 4 on the outside, because technically you need to multiply 4 by both of them. Or it's okay if you go ahead and just multiply it out. So you could say 4k plus 4q. Either one of those is okay. Means the same thing. Thank you for all the commentary. It is wonderful. Okay, the 3 is sitting next to the a, which means multiply. How do I cancel out multiplication? I divide. So your final answer could look like this. It could be a equals k plus q times 4 over 3. Or it could be 4k plus 4q over 3. Either one of those, it's two different ways of saying the same thing. Okay? So,